A more advanced way of approaching division would be through the use of division clusters. Once students have gained an understanding of the concept of division, and once they've explored the use of multiplication clusters, they can then apply those understandings into this process. With the process of division clusters, students create a list similar to this of familiar division problems that can be solved using mental mathematics. After generating this list, 16 divided by 16 equals 1, 32 divided by 16 equals 2, 80 divided by 16 equals 5, they can use these problems to help them solve more advanced problems using mental math, such as these. If they know that 16 divided by 16 equals 1, they're able to solve for 160 divided by 16 to determine the quotient of 10. Again, 32 divided by 16 would help them understand 320 divided by 16 as 20. And 80 divided by 16 would help them solve 800 divided by 16. Instead of 5 being the quotient, they would have a quotient of 50. After brainstorming a list, they would find several of these problems that are useful in decomposing this dividend down into smaller problems, creating a cluster in order to help solve. For example, this problem would be useful in helping to solve for our original problem, 160 divided by 16 to equal 10. Because what we have done is consider 160 of the original 192, and we have found that there would be 10 groups within that amount. So considering the difference, if we've taken away 160 and placed them into 10 equal groups of 16, we have 32 left to consider. Going back to the original thinking, if they know that 32 divided by 16 equals 2, they have created a division cluster, which shows that when we are dividing into groups of 16, that 160 leaves 10, 32 leaves 2, so altogether 192 divided by 16 gives us a total of 12, which is our quotient. Once arriving at the quotient, students write their answer in a complete sentence. The question being how many groups were formed. 12 groups were formed from the original word problem.